Suppose if you remove a vertex from the graph, then that is denoted as G minus V. Now a cut vertex of a graph is a vertex such that the removal of the vertex makes the graph disconnected. A single edge is removed from the graph, then it also becomes a disconnected. That is called as a cut edge. A connection between pair of vertices without repetition is called the path. Hello dear students, welcome to this session of Discrete Mathematics class. I am Mr. Niranjan, Faculty Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence. Now, in my previous class, we have discussed regarding the definition of graph and how to construct a graph. Now, in this session, I am going to discuss regarding very important concept like that is cut vertex, cut edges and the path, and different types of problems based on cut edge, cut vertex and the path. Let us come to the first concept. The first concept is the removal of vertex and an edge. Now, what is this removal of vertex and an edge? Just removal is nothing but the separating, that's all. Suppose, see here, suppose if there are, this is a graph, and so suppose if I represent this as V1, V2, V3, V4 and V5. So the edges are E1, E2, then E3, E4, E5. Suppose this is the graph. Then if this V4 is removed, if V5 is removed, then the graph will becomes like this. That is V1, V2, V4 and V5. So this V5 is separated. Sorry, this is V3. So this is separated. If you separate this, that is called as the removal of a vertex. Right, listen to me carefully, I will explain it. Let G, V comma E, let G is the set of vertex and edges, be a graph. Removing a vertex V belongs to V from the graph G, we obtained a graph denoted by G minus V. Suppose if you remove a vertex from the graph, then that is denoted as G minus V. The vertex is removed from the graph is denoted as G minus V. That is, let G is equal to V comma E be a graph removing a vertex. So if you remove a vertex from the graph, let us assume V is the vertex which is removed from the graph. From G, we obtained a graph given by G comma V. Similarly, removing an edge E from the graph is nothing but E belongs to E, results into a graph which is denoted as G minus E. Suppose if you remove a vertex from a graph G is equal to V comma E, then if you remove a vertex, V is removed from the vertex, then this becomes G minus V. And an edge is removed, then this can be denoted as G minus E. So, removal of a vertex or an edge increases the number of components of the graph. So, if you remove the vertex or an edges, that will increases the number of components of the given graph. Now let us consider an example for a removal of a vertex and an edge. Let me explain by taking an example. Okay. Let us explain by taking an example for a cut vertex. Let us come to the first concept, cut vertex. Now a cut vertex of a graph is a vertex such that the removal of the vertex makes the graph disconnected. If a vertex is removed from the graph, then the graph is said to be disconnected. It becomes discontinuous. The graph is said to be disconnected or continuous. Now, let us take an example. Let us consider a graph. This is V1, V2, V3, V4. Another one is V5. The edges are E1, E2, E3, E4 and E5. Now, according to the definition, a cut vertex of a graph is a vertex such that the removal of the vertex makes the graph disconnected. According to the definition, a vertex, removal of vertex, removing a vertex V comma E from the graph. So, if you remove any vertex from this, suppose let us remove this vertex 5, then this graph becomes disconnected. That is V1, V2, V3 and V4. This V5 is separated. This V5 is removed from this. Then this is E1, E2, then E3, E4. This is an example for a cut vertex. This is an important concept for the point of examination. So if we separate this vertex 5 is taken out from this graph, then this graph is said to be disconnected, and this is called a cut vertex. This is the best example for a cut vertex. You can also remove any other V1 and V2 or V3, like that. You can take any vertex from this graph so that the graph will becomes disconnected, right? So here we are removing the vertex. That's it. This is called the cut vertex. Now let us come to the next concept, cut edge. What is meant by a cut edge? So a bridge is a single edge whose removal disconnects the graph. Cut edge is nothing but, this is also called as a bridge. This can also be called it as bridge. Cut edge, or it is also called as a bridge. So a bridge is a single edge whose removal disconnects the given graph. So in the previous cut vertex, if a vertex is removed, then this will also become a disconnected graph. So similarly, if a single edge is removed from the graph, then it also becomes a disconnected. That is called as a cut edge. So removing an edge from a graph is called the cut edge. So a bridge is a single edge whose removal is disconnects the graph. Now let me explain how to remove an edge from the graph by a small example. Now let us consider what is this V1, V2, V3 and V4. So these are the 4 vertices. Okay. Now let us write one more vertex Y and V5. This is V6, V7. So what are the edges here? Here this is E1, E2, E3, E4, E5. Then this is E6 and E7, E8. So this graph contains how many edges? So this contains 8 edges and 7 vertices. So 8 edges are there and 7 vertices are there. Okay. Suppose let us remove one edge, removal of a single edge. If a single edge is removed, one edge is removed, let us remove this edge E5. If E5 is removed, then this becomes, the graph will become the disconnected graph. See, this will disconnect and this will become the separate graph. That is V1, V2, V3 and V4. The edges are E1, E2, E3, E4, and this will become the separate, that is V5, then V6, V7. The edges are E6, E7 and E8. This is the best example for a cut edge. So here we have removed the edge. E5 is removed so that this graph becomes disconnected, and thus we are going to get two graphs. So as I told in the previous explanation, if the removal of a vertex or edges increases the number of components. So here one component is changes to 2 components. Okay. This is an example for a cut edge or a bridge. Okay. So in general, a bridge is nothing but, if a bridge is a single edge whose removal will disconnect the given graph. That's it. Okay. Now let us come to the next concept, connected and disconnected graph. So this is an example for, so connected and disconnected is nothing but the removal of an edge or a vertex. That's it. A graph G is connected if there is a path between every pair of vertex. If there is a path between every pair of vertex, then the graph is said to be a connected graph. So from every vertex of any other vertex, there should be some path to traverse. Then for a connected graph, there should be a path between every pair of vertices. So every pair of, if there is a path, if there is a direction for every pair of vertex, then the path is, then the graph is said to be a connected graph. So for every vertex to any other vertex, there should be some path to traverse. Now let me explain by a small example. Now let us consider, this is V1, V2, V3 and V4. So E1, E2, E3, E4 are the edges. So according to the, a graph is connected if there is a path between every pair of vertex. So V1 to V2 and again V2 to V3, again V3 to V4, again V4 to V1. So if there is a path between any pair of vertex V1 comma V2, again V2 comma V3, and again V3 comma V4, and similarly V4 comma V1. If there is a path, is direction, then the graph is said to be a connected graph. Okay, so there is no disconnection, between any pair of vertices, right? If there is a path to travel from one vertex to another vertex, then they are called as the connected vertex. Let us consider one more example, vertex V1, V2 and V3. So here, so V1 to V2, V2 to V3 and V3 to V1. This is an example for a connected. Now, if there is no connection between any two pair of vertices, then the graph is said to be disconnected. Let us consider, for example, V1 and V2. So, if there is no connection between V1 and V2, the pair of vertices, then this graph is said to be disconnected. Suppose if I write one more example. So, this is V1, V2 and V3. So, there is no connection between these three vertices, V1, V2 and V3, then this graph is said to be a disconnected. There is no connection, there is no continuity, then the graph is said to be disconnected graph. That's it. Very simple and important concept. Okay. Now, let us come to the next concept. Path. Path means if no vertex is repeated. If no vertex is repeated, then it is called as the path. Okay. That is, the connection of pair of vertices, the connection between pair of vertices is called the path without repetition. If there is no repetition, no vertex is repeated, then it is called the path. That is, a connection between pair of vertices without repetition is called the path. Now, let us consider, for example, this is an example for a path. See, this is V1, V2, V3, V4 and V5. The edges are E1, then E2, E3 and E4. So, here the starting point and the ending point are different. See, here V1 is the starting point and the ending point is V5. So, the starting point and the ending point for this graph is different. So, therefore, there is no vertex is repeated, then such a direction is called as the path. Then this is said to be an example for a path. So, that means here the starting point and the ending point are different. So, therefore, there is no vertex is repeated, then this graph is called a path. So, if no vertex is repeated, then the graph is called as the path. Next, let us come to the next, walk. This is very important concept. A walk is a sequence of vertices and edges of a graph. So, it is a sequence of vertices as well as the edges. That is, if we traverse a graph, then we get a walk. The traverse is called the walk. So, vertex can be repeated, edges cannot be repeated. So, we can repeat the vertex can be repeated, whereas an edges cannot be repeated. Let us take an example for a walk. Okay, let me explain by taking a simple example. Visiting each and every node exactly once is called as a walk. So, we have to visit each and every node only once, that is called as a walk. Okay. Now, let us take an example. So, here there are 1, 2, 3, 4, 5 vertices are there. So, vertex can be repeated, whereas the edges cannot be repeated. Let us take an example for this walk. So, there are 4 vertices V1, V2, V3, V4, V5, that is represented by 1, 2, 3, 4 and 5. Now, let us give the direction 1 to 2. So, 1 to 2 is one path. Again 2 to 3, 2 to 3 we have 2 to 3, this is 2 to 3. Again from 3 to 4, 3 to 4. Again from 4 to 2, 4 to 2. Again from 2 to 1, again 2 to 1, and again that is from 1 to 3, 1 to 3. This is called the walk. So, a walk is a sequence of vertices and edges of a graph. That is, if we traverse a graph, then it is called as a walk. This is an example for a walk. Okay. Now, let us come to this one. Here 3 to 4, again 4 to 5, 3 to 4 and 4 to 5. Here this is not a walk, this is not a walk, because here already 3 to 4 is visited. We have visited 3 to 4. So, 3 to 4 is already visited. Therefore, this is not an example for a, this is not a walk. See here 3 to 4 and 4 to 5 is a not walk. This is not a walk because already 3 to 4 is visited. 3 to 4 is already visited. So therefore, we can consider this is not a walk. So this is an example for not a walk, and whereas this is an example for a walk. Okay. Hope you followed it. Right. Now, suppose if the starting point and ending point for the graph is same, if the starting vertex, if the starting point and the ending point are the same, then the walk is called a closed walk. Then it is called as a closed walk. Suppose if it is like this, A to B, again B to C, again C to A, then this is a closed walk. This is an example for a closed walk. Okay, if the starting point and the ending point are the same. Now let us come to the next one. Open walk. There are two types of walks, that is open walk and a closed walk. Walk is said to be an open walk if the starting and the ending vertices are different, that is the origin vertex and the terminal vertex are different, then it is called as the open walk. So if the starting point and the ending point are different, then it is called as the open vertex, that is the starting and the ending point, the initial and the terminal point are different, then it is called as the open walk. Whereas the closed walk means walk is said to be closed if the starting and the ending vertices are identical, that is walk starts and ends at the same vertex, then it is said to be a closed walk. Now let us take an example. Let me take a small example for open as well as the closed walk. Now, in this diagram, let us come to this diagram. Here there are 1, 2, 3, 4, 5 vertices V1, V2, V3, V4, V5 are A, B, C, D, E. Now, let us come to the first example as an open walk. So, here it will start from 1, 1 to 2, 1 to 2, again 2 to 3, 2 to 3, again 3 to 4, 3 to 4, again 4 to 5, 4 to 5, 4 to 5, again 5 to 3, this will goes to 3 again, 5 to 3, again that's it. So 5 to 3, right. See here 1 to 2, 1 to 2, again 2 to 3, 2 to 3, again 3 to 4, 3 to 4, again from 5 to 3, so 5 to 3, 4 to 5, first it is 4 to 5 and again 5 to 3, that's it. So what you say here, the starting and the ending point are different. So the starting point is 1 and the ending point is here it is 3, ending point is 3, that is the terminal point is 3. Therefore, this is an example for an open graph. So open graph is said to be one in which the starting and ending vertices are different. Here the starting point is 1 and the ending point is 3. Therefore, this is a open graph. So a graph in which the starting point as well as the ending point, initial point and the terminal point are different, then it is called as an open graph. Now let us come to the second one. What is the closed? In closed graph, the starting point and the ending point must be same. So let us come to the second type of graph. So the same problem. Now let us take an example. So it will start from 1 to 2, 1 to 2, again 2 to 3, 2 to 3, again 3 to 4, 3 to 4, again 4 to 5, from 4 it is 5, again 4 to 5, again from 5 to 3, 5 to 3, again from 3 to 1. See, this is closed. The blue line indicates it is closed. So here the starting point is 1 and the ending point is also 1. So it starts from 1 and the ending point is 1. So therefore, this is an example for a closed walk. So very simple concept. What is meant by a open walk and closed walk means in an open walk the starting point and ending point are different, whereas in a closed walk the starting point and the ending point both are same. So it will start at 1 and ends at 1. This is an example for a closed walk. It will start at 1 and ends at 3. Therefore, it is an example for a open walk. That's it. Now, what's a trial? Actually, it is an open walk. A trial is an open walk in which no edge is repeated. A trial is an open walk in which no edge is repeated. Vertex can be repeated. So here vertex can be repeated, but edges cannot be repeated. Such a walk is called as a trial. So a trial is an example for a walk. A trial is an open walk in which no edge is repeated. Vertex can be repeated. So let us take a simple example. Here there are 9 vertices. 1, 2, 3, 4, 5, 6, 7, 8 and 9 points are there. Now let us come to an example for a trial first. So here let us connect 1 to 3, 1, 1 to 3, again 3 to 8, 3 to 8, this is 3 to 8, again 8 to 6, from 8 we are going to connect 6, 8 to 6, again from 6 to 3, 6 to 3, again from 3 to 2, 3 to 2. So this is an example for a trial. See, that is 1 to 3, 1 to 3, again from 3 to 8, again from 8 to 6, again from 6 to 3, again from 3 to 2. So 1 to 3, 1 to 3, 1 to 3, again 3 to 8, again 8 to 6, 6 to 3 and 3 to 2. So this is an example for a trial. That is, a trial is an open walk in which no edge is repeated. So nothing, no edge is repeated. This is an example for a walk. Now, suppose let us consider a closed trial. What is a closed trial? Here in closed trial, the starting point and the ending point are same, whereas in the closed trial, open trial, starting and the ending point are different. Whereas in the closed trial, starting point as well as the ending point are same. What is the ending point? That is a starting vertex and ending vertex are same. Now let us take an example. Now 1 to 3 same, 1 to 3, again 3 to 8, 3 to 8, again 8 to 6, 8 to 6, again 6 to 3, 6 to 3, again 3 to 2, 3 to 2, again 2 to 1. So this is an example for a closed trial. 1 to 3 same, 1 to 3, 1 to 3, again 3 to 8, 8 to 6, 6 to 3, 3 to 2, and the ending point is, again we came to the same initial point, that is 1. So here the terminal point is 2, here the terminal point is same as that of the initial point. So therefore this is an example for a closed trial. So in general, trial is an open walk in which no edge is repeated, vertex can be repeated. Let us come to the next one, Eulerian graph. Eulerian graph. So Eulerian graph, this is very important. You may expect one question from this. Eulerian graph or Euler's graph is a graph in which we draw the path between every vertices without retracing the path. These are undirected graphs. So without retracing, a graph which is written without retracing is called an Euler's graph, or it is called as a Eulerian graph. Eulerian graph, or it is also called as a Euler's graph. Without retracing, a graph which can be drawn without retracing the path is called is an Eulerian graph, or it is also called as a Euler's graph. Now let us take an example. Now, let me explain one with small example. Let us start with V1. See, V1, V2, V3, V4, V5, V6. This is an example for a Euler's graph. So without retracing, we are going to get a graph. Okay. So let us take an example. Here A to B, B to C, again C to A, again this, again from G, again from G to F, again F to C, again from C to D, again from D to E, again from E to F, again from F to this, and D to E. Starting point is A itself. This is an example for a Euclid. So here without tracing the path, we are going to draw. This is an example for an Eulerian graph. Let us come to the next one, Eulers path. This is also very important. They will ask one question from Eulers path. Eulers path is the path in the graph that contains each edge exactly once and each vertex at least once. So Eulers path is the path in the graph that contains each edges exactly once and each vertex at least once. So that is each edge exactly once and each vertex at least once we have to connect. So that such graph is called as a Euler's, that path is called an Euler's path. Now let us take an example for this. Now let us come to the simple example. Here it will from A to E, again from E to C, again from C to A, again from A to B, again from B to C, again C to F, F to E, again E to D, D to E. So this is an example for a Euler's path. Okay, that's it. That means Euler's path is the graph that contains each edge exactly once and vertex at least once. Now, let us come to the Eulers circuit. So, if the starting and ending vertices are same in the graph, then it is known as the Eulers circuit. This is an example for an Eulers circuit. So, here the starting and the ending point are the same. If the starting and ending point are the same, then it is called as an Eulers vertex. Now, see, let us start with this. So, here V1, V2, V3, V4 and V5. So, it will start from V1 to V5, then V2, V3, V4 and again V1. Okay, this is an example for you. So, that is here the starting point and the ending point are same. That's it. If the starting and ending vertices are same in the graph, then it is called as the Euler's circuit. Another example, we can also write this V1, V2, V3, V4. So, it will start in this direction, again, it will comes to this. This also example for a Euler's circuit. Okay. So, these are regarding the basic things in a graph theory. That's all regarding today's session. Let us meet with a different concept in the next session. Thank you very much.